All right, thank you everybody. Thank you for joining Next Level Availability on SQL Server 2022. My name is David Pluss. I'm a Principal Program Manager on the Storage Engine and on Azure SQL VM. We're going to talk about availability, and I think it's a measure of a successful DBA, is having a recovery plan and being able to keep your organization's data available as much as possible. So we're going to look at current availability options, SQL Server 2022, kind of the concept of what is Hatter. You know, you hear it thrown around so much, and really the journey that we took getting here. Okay, so we know that downtime is costly in terms of lost productivity and revenue, and it's like availability is job one of a DBA, right? So the thing is how often have we really looked at what we've made from an investment perspective in terms of like server hardware, storage devices, infrastructure components? And the question is, are we taking full advantage of that hardware? Are we taking full advantage of the storage? Are we taking full advantage of the duplication of processes and services that really leans to what we get when we have a high availability disaster recovery strategy? And then have we taken a full assessment of what it would mean if we lost connectivity, if we lost the ability to recover? How much data could you lose? How long could you be down? I mean, if you ever tried that question as a consultant, how long can you be down? None. How much data can I lose? 0. Awesome. This is what it's going to cost. So, okay, maybe I could lose a little bit of data. Maybe I could be down a little bit. Okay, so let's talk about what is that a little bit. And this is where we get to our service level agreements. This is where we get into a negotiation. I mean, I think a service level agreement is essentially a negotiation from an organization's perspective. What it will mean to the business and trying to achieve as many nines available. That's what we tend to do when we are measuring our availability, right? So let's talk about that. Talk about what that means. So you've seen this slide probably a couple of times. I've hit the scalability stuff. I did this session with Ajay just yesterday. And we have everything that's really on the right here. So always on availability group improvements linked to Azure SQL Managed Instance, multi-write replication. This is the last writer wins concept. Intel Quick Assist technology backup compression. I had to kind of break that off. We had a session yesterday with Bob Ward and with Intel, and I just had this drop just this week. It's a session I did with Anna Hoffman. It's actually, I took the demo that I did for the Intel Quick Assist technology scenario and really kind of broke down what the moving parts in the demo and explaining why you would want to use accelerated backup compression, hardware offloading, software-based compression, and how that would really help your environment. So definitely take a look at that. We're going to wrap up the session with T-SQL Snapshot backups. It's like a native solution. So you can use your storage snapshot rather than streaming backups. Talk about what that means. And then accelerated database recovery improvements. So what I got polling folks here is that there's a whole lot of people on 2019, but not a lot of folks have opted into ADR. So we definitely want to talk about that. Okay, so here's kind of the grouping that we have of the areas that we're going to cover today: distributed availability groups, link feature and SQL Managed Instance, availability group performance and scalability enhancements. This is an area that gets just kind of lost a lot. I think it happened in 2016. I think it just tends to happen because we made it faster. Oh, okay, well, thanks. That's nice. But what was done to make things faster? What does faster look like? And why? I think that's important. Peer-to-peer replication with the last writer wins, contained availability groups. This is the one I really think Kevin Farley does it best, so we're going to take a look at what he does, and he has a really good narrative around that. T-SQL Snapshot backup, and then the ADR improvement. So these are the areas that we're going to have from a demo perspective. Okay? All right. Doing good on time. I'm always kind of checking time. So what is this Hatter thing? You hear a lot about it as if it's like this single monolithic thing. We just say Hatter. You know, it's why I kind of like business continuity and disaster recovery, because it stops us from saying Hatter. So, you know, what is this concept and why do we break it out? So I'm definitely going to give you some perspective here. I'm going to give you my personal perspective. Actually, we were debating with David Levi about this about a week ago. It's like the perspective, the lens that you have on disaster recovery and high availability. Now, for me, I was a DBA at an electronic bill payment company. So downtime meant just fires, right? And any hiccup got everyone's attention. It's like everyone's kind of leaning on the back of their chair, like they're afraid they're going to fall over, that sense of panic. Imagine feeling like that all the time. That's what it could be like as a DBA in an environment like that, when it's absolutely mission critical and all eyes are on you if you have an issue, right? Okay, so disaster recovery. Here, when you think of this, think in terms first of lack of access and then potential data loss with the scenario that you may not know, right? You may have no idea what's going on, what happened to that site. So it usually involves recovering from an event which could take the entire infrastructure offline. It could be a smoking hole in the ground. You have no idea. So when you think of disaster recovery, you really should be thinking like something majorly catastrophic. Now, where I'm from, it's hurricanes and sinkholes. It's not necessarily something like this. I live in Florida. So not necessarily something like this, but you need to be prepared for that and think of the scenario. Imagine being on the east coast of Florida and having your DR site 5 miles down the road. Hurricanes just tend to go, just up the coast. So, So be thinking about that and thinking of the strategy and starting with recovery. Like you hear people talk about, I have a backup strategy, have a recovery strategy. Start with that concept. So for disaster recovery, you need to assume that your site is not accessible. It could be for an extended period of time. It could be no communication whatsoever. Again, you don't know what you're looking at. It could be a smoking hole in the ground. You have no idea. Usually, now this is not true for everyone, so this is insert opinion here. Usually getting back online and available is more important than not losing any data. That's not to say it's never okay to lose data. But the way I look at it, especially for an OLTP type of scenario, customer workload scenario, as long as you're down and unable to take customer orders, aren't you still losing data? I mean, that could be affecting customer perception, right? So if you're down and you're extended period of time down, okay, what does that mean from an SLA perspective as well? So from a DR perspective, there's not just the data loss component, what we tend to call a recovery point objective, but there's a time objective. So from that perspective, from that lens, disaster recovery is taking an action or having the technologies in place beforehand to ensure that when a failure occurs, you recover any lost data and make it available again, with time being a critical factor. You've got to get up as quick as possible and try to avoid losing as much data as possible. Okay, so it tends to be a lot of duplication of technologies and scenarios to make this a thing, with time being a critical factor. Now, on the other hand, high availability is maintaining availability of a surface system with absolute minimum, ideally zero downtime. Absolute worst, we want a minor hiccup or disruption. This is, okay, this to me, this is, again, another perspective here. I don't want the customer to see anything. I don't want the customer to notice anything at all. You could, let's say it's a streaming service, you're watching videos or whatever. That's what you're providing. It's like, oh yeah, did you hear the news? This site had this huge outage and a couple of servers went down or whatever. You're like, I was watching movies all night long. I binge watched half the season. I didn't notice anything. Beautiful. So you were able to consume completely, and there was duplication of hardware and services, data and services, so it's totally masked to you. And to me, the mask is everything. Okay, so high availability is about putting technologies in place to ensure that any issues affecting the user experience is minimized to the maximum extent. I want it to be completely masked. I don't want the end user to see anything. So what that means from a high availability disaster recovery perspective as a DBA, if the database is up, now here's the thing, y'all may have a totally different arrangement as far as responsibilities go, I get that. But if SQL Server's up and you can query the database but the application can't connect, are you up? You can be up from the DBA's perspective, but from the application stakeholder's perspective, are you up? How does that affect your service level agreement, and how does that affect your standard operating procedures? I argue from an organization perspective, there should be a holistic approach to availability and the lens of the customer. Okay, just perspective. So we measure availability in terms of this recovery time objective, which I mentioned. It's the amount of allowable downtime when a failure occurs. And a recovery point objective is the maximum allowable data loss when a failure occurs. We tend to look at this now I'm kind of like shifting this whole conversation to what an availability group would represent, to the send queue and the redo queue. Send queue is what hasn't been sent yet. It's still in the primary, trying to go to the secondaries. The redo queue is on the secondaries. It's what it would have to apply, redo in order to get back up. So if I have the Whopper from War Games as my primary and a gateway desktop I bought off of eBay as my secondary, I may struggle getting that data applied in the case of a disaster. Right? It's a really weird analogy. I don't know why I used that, but I did. So think that in those terms. You want your primary and your secondaries to be somewhat equal when it comes to from a performance perspective. Okay? All right. So let's go over a brief history of header features in SQL Server. There's a reason I'm doing this. This isn't just like a laundry list for no reason. I'm going to be picking out certain things that helps build on what we've had and becomes important in 2022. Okay? Oops. Did I click back? No, I didn't. Oh, good. So let's start with SQL Server 2000. 2000, we had failover clustering, log shipping, and backup restore. And we often mix these topologies together. I'm going to tell you something. It is 2023, and I absolutely love log shipping. It's beautiful. It's simple. It works. There's a reason why a lot of people still use it. Yeah, agreement, right? Is log shipping awesome? Yeah. So DBA is an awesome DBA method for disaster recovery especially. But I'm not a big fan of reporting off of log shipping sources. So in 2005, database mirroring, huge, right? It really started the chapter of what we had at AGs later. Database snapshots, if you're looking to revert, it created that NTFS sparse file, which was handy for certain scenarios. Fast recovery, the ability to do online restores. In 2008, log stream compression, big deal from performance. Automatic recovery of corrupted pages, big deal to have a replica be able to correct another replica if a corrupted page is found. In 2012, this is where we got always on availability groups. The flexible failover policy was very handy. Like if I needed to adjust the sensitivity from a failover perspective, right? Very handy situation. In 2014, this is all like improvements to always on availability groups, expanding to 8 replicas and having online replicas even after quorum loss where we could service read-only access because there's no risk of data corruption, right? So we just continue servicing read-only connections even after quorum loss, which is a really big deal. So you're just continuing to have your read-only reporting workloads continue to function, which is powerful. Okay, so in my opinion, this is when always on availability groups started to get really, really good. And there's some key things here. This is when we gave availability groups support to standard edition, load balancing of read intent connections for multiple secondaries. This is that round robin access for reporting. And we saw a lot of people use this with reporting services. It was really powerful. 3 auto failover replicas. The key one I want to mention here, and there's a reason why it's bold, is distributed availability groups. Anyone using distributed availability groups? Okay, right. Able to link separate AGs across 2 independent Windows Server failover clusters and/or Linux for multi-region or hybrid deployment. It's an availability group of availability groups. Okay. And of course, and I mentioned this before, log transport performance is completely overhauled in 2016. So the performance was dramatically improved of sending data over the wire for the purposes of availability groups. Really big deal. So having that come out at the time of distributed availability groups, It was important. Okay, but distributed availability groups, keep that in mind as we go along, because we build upon that. SQL 2017, all about choice, but the big deal here is for SQL Server on Linux, you could use a third-party clustering solution like Pacemaker or Service Guard. We had full DTC support, read scale availability groups. This can be set up without any kind of clustering infrastructure underneath for read-only traffic to specific replicas. It essentially allowed you to create an availability group for read-only workloads. It's not a high availability configuration. It's purely designed for that scale-out read-based workload, especially for reporting. The new cluster types, that was external and none. It was actually to support the Linux scenario, and there was additional support going forward. And then in 2019, this was really kind of like helped out Azure SQL VMs quite a bit. The support for dynamic network names. Previously, you had to use an Azure load balancer, and it was required to set up clustering with Azure SQL virtual machines. But a dynamic network name makes that way, way easier, right? And then, of course, Azure shared disk support for failover cluster instances. So it basically helps IaaS scenarios as well. So it kind of catches us up to 2019. I know I didn't mention the ADR piece there, but that wasn't specific to availability groups. We'll get to that in a bit. So now let's talk about the features that we're going to have in 2022. And I really want to kind of hone in on this stuff. This is the distributed availability group failover improvements, perf and stability improvements that you just get by getting on 2022, multi-write replication, and there's some application scenarios with that, managed instance link, which is an Azure-based technology feature, and then contained availability groups. Okay, so let's talk about distributed availability group failover with no data loss. Okay, so this was intended for remote locations. Again, I think I describe it as an availability group and availability groups. So we have, again, two separate availability groups to be linked across an independent Windows Server failover cluster or Linux deployment. And it's designed for multi-region or hybrid deployment scenarios. So what distributed availability groups are doing is they resolve these quorum issues between sites. So if you have a single quorum across a bunch of sites and there's a network outage, it can cause remote sites to lose quorum and take down services, even if they're perfectly healthy. Distributed availability groups improves when network efficiency and enables mixed versions because you don't have to have a common cluster. Problem with this is like the strength can be somewhat of a weakness, right? So it sounds great. It's like this no free lunch kind of thing. Without having a central cluster manager, there's no way to synchronize failover. So it's been generally difficult to guarantee zero data loss in failovers, but because the two sides are not talking to each other. So there's no way to say in terms of LSNs which have been persisted and which haven't. Okay, that makes it complicated. So what we've done is we've given an ability to ensure zero data loss for distributed availability groups. So the benefits here are synchronized secondaries to commit feature ensures that no transaction will be partially committed. And it's way easier to address than having to deal with the LSNs on both sides. It doesn't make failover automatic. But it does guarantee zero data loss. Now here's a problem, well, I shouldn't say problem. It depends on the scenario you're in. If you say that you want zero data loss and this is something that you need to have, then you're gonna opt in for that scenario, but there's gonna be somewhat of a performance penalty depending on, really depending on the network option between sites. So the default option is 0, it's the same behavior as 2016, it's also the minimum. And the maximum is the number of replicas minus 1. Okay. Now, I don't recommend just staying in this mode all the time unless your scenario calls for that because of the somewhat of the performance penalty. In order to enable it, you just do an alter availability group. Okay. So this is something that can be adjusted after the availability group is created. All right, so linked feature in SQL Manage Instance. Okay, so thank you. The link feature in SQL Manage Instance is a new feature. I thought it'd be 20. No? I thought we started at 12. Oh, 30 minutes left. Thank you. Okay, link feature in Manage Instance is brand new, enables you to have a connection between SQL Server on-prem and Manage Instance. So you essentially have a hybrid connectivity scenario. So basically it allows you to get to Azure at your own pace. You can modernize in the cloud while running your existing on-prem scenario and then just migrate when you want to without any downtime. And then you can use Manage Instance as a disaster recovery site only for SQL Server 2022 because we're maintaining the database file versioning between SQL Server 2022 and Manage Instance. Okay? But it's that DR ability to come back is for 2022 deployments. Okay, so you can see from the green arrow there, we're replicating databases from on-prem into Azure SQL in near real time. So we're maintaining an identical copy of your on-prem database within SQL Server in Azure. So the concept is allows you to migrate or replicate data and offload analytics to Manage Instance. You can use some of the analytics functionalities on SQL Server or on your Manage Instance database while keeping your core SQL Server running on-prem, using everything that you're currently doing now, right? Same tool set, same experience. You can offload read-only application workloads to SQL Server Manage Instance. So you could send like your read-write to on-prem and then all of the read-only workloads to Manage Instance in Azure. You can take a consolidated approach or a deconsolidated approach. Consolidated approach would be saying that in all of the scenarios that you have on-prem that you're going to a single Manage Instance. Deconsolidated approach would say that I want my Manage Instance link to go to a Manage Instance site close to where my customer is or my customer workload is. But this unlocks a ton of scenarios like read-only workloads, analytics, any kind of thing reporting to Manage Instance and migration. Okay, awesome from a DR perspective. Now, I should have gone forward. My bad. Yeah, and then you can migrate when you're ready. Check out the link, the AKAMS MI link for more details. But yeah, this is the concept. Now, how does this work? Managed Instance Link is based on distributed availability groups. That's what's happening underneath. That's why I told you what I told you to tell you about this. So it's a distributed availability group, and this is important because under the covers, it depends on the scenario what is supported. If you're on SQL Server 2016, you are going to need a single node Windows Server Failover cluster instance. It's not required for 2019 and up. Okay, but we are using a distributed availability group underneath to power this scenario. Okay. This is AG Perf and Stability enhancements. There's one in particular for hosters I think is going to matter quite a bit. Okay, so the first item is two TCP channels for log replication. So by adding a TCP channel, we get much better throughput across the availability group or distributed availability group links. This was a choke point for quite some time. So we just needed better throughput, so adding that additional TCP channel gave us that. If you have a scenario where you have a lot of databases, hosters come to mind here, and there's a few scenarios, customer scenarios that I can think of where this was affecting them. So if you think about failover, anytime a database is coming online, one of the operations that you have to do is redo. So redo operations have to go through and redo any incomplete transactions in the database, and if you have a bunch of databases, it could be a problem with thread allocation. So prior to SQL Server 2022, we statically assign 100 threads per database. But once we get to that point, we've exhausted that number, we assume that the remaining databases just need one logical thread each. And let's say that you have a big mission critical database and it's doing a lot of work and there's a lot of redo. So that just one database is having a bad day. Just all of a sudden. So what we've done to address that is we've re-architected the whole scenario, and now we have a global thread pool for redo work. So there's a global set of threads that are dedicated to doing redo. In general, optimizing the redo experience. And it may not sound like you just get this by default on SQL Server for 2022. It may not sound like a big deal, but if you've had that kind of performance impact from a thread perspective, the redo thread perspective, or just general performance over the wire, it's just to know that this has been optimized in SQL Server 2022. Also make it easier to troubleshoot. So there's been some additions to SP Server diagnostics. So when reverting occurs, the secondary server must undo changes when it's already been applied in order to get back in sync with the primary. And we've made it a lot easier to troubleshoot, essentially putting in the SP Server diagnostics extended event output what you would see from a recovery perspective in the SQL Server error log. Just way easier to troubleshoot. And so we've also, another design change was to improve always-on health and system health logs. So we just have richer information from a debugging perspective. And we've improved the always-on connectivity. So we have basically, instead of doing things from a first-come, first-served basis, we prioritize connections based on how much work needs to be done. So basically, the most important work is completed first. So we bias towards getting that work done rather than it being first come, first serve. So basically, an unfair mutex is the way that's described. Okay, peer-to-peer replication with last writer wins. This is a big deal. If you're in this scenario, I have a particular customer. It was a sales-based application. I'm trying to be careful not to say the name. Where they needed to have some sort of last writer win scenario. Because that wasn't in place, they ended up implementing a merge replication scenario to work around this situation. Anyone using peer-to-peer replication? Oh, one. I was about to say no one, but there's one person. Okay. So this might be a big deal for you then. Okay, so it's built on the transactional replication model. It provides scale out and high availability by maintaining copies across server instances that we call nodes. So prior to 2022, with peer-to-peer REPL, each peer is assigned an originator ID. If there's a conflict, the highest ID is the winner, no matter what. And it's just the way it was implemented. So it would win. So this is not necessarily the design outcome that you would want, certainly not from an application scenario, which you may expect. So now we have this new last writer wins conflict resolution method. So we basically record a timestamp for each column. It's a hidden column. And if a conflict's detected in a small window, the last writer is going to be the one that's going to win. So in the scenario that we have here, oh, I should have gone forward. Yeah, these are some just key points here. The scenario that we have here, so this one at T0, let's say this user is updating row 1 and setting A to 45. T1, this user is updating row 1 and setting it to setting A to 23. Previously, with 45, without last writer wins, let's say the first one was the highest originator ID, would win no matter what. Now in 2022, with last writer wins, it's going to be based upon that timestamp column, and it makes a lot more sense from an application perspective, especially if you have like if you're tying your application model to peer-to-peer replication, and you need to influence the behavior for the last writer win scenario. All right, contained availability groups. Okay, this is really powerful addition. It's a really big deal. Got a pretty good reaction in Bob's workshop. So the problem we're trying to solve here is when you set up an availability group, there's all these objects and settings that are not part of the databases being replicated. So it could be like users, logins, jobs, et cetera, that don't get replicated across the instances. All of these settings have to be kept in sync, and they traditionally were not replicated. So even if you added a user or login within the context of an existing availability group, we didn't replicate it to the other replicas. So what do folks typically do? And I'm interested in what y'all do. Some people have some complicated scripts. They have maybe some PowerShell scripts. They may be using SSIS packages to try to replicate the
DBA tools.
DBA tool. What DBA tools?
They have basically dba-tools.io has commands basically to replicate all of those.
Okay.
You can nominate multiple servers and it will sync everything up.
Fantastic. And I love that there's solutions out there. So DBA tools helps with this. I say this is a critical thing from a disaster recovery perspective because again, let's use the point I started with. Oh, the databases are up. Fantastic. Are the jobs there? Not yet. No. So we're still down. If I need those jobs, we're down. So I need to have something to replicate it. It's good that there's third-party scenarios. It's hopefully something that is fairly easy to do when you have a disaster scenario in place. But we've tried to solve for that in SQL Server 2022 as well. So what we need is a unified experience across all the instances. All operations within the AG should require no syntax change. Other than just saying it's contained, and we have one other statement that if you need to reuse the system databases, this is all based upon. We need to simplify the disaster recovery process as a key thing when you need it the most. The last thing you need is moving parts that makes things more complicated. Okay, so here's all the changes. Now this is something that's only done at creation time. There's no alter availability group to make it a contained availability group. Okay, so contained is the keyword that you need. Reuse system databases, that refers to if you have a local system database as part of the AG. It just means if you've dropped a contained AG and you want to recreate it, use this flag to tell it to reuse those system databases that were left from a previous availability group. So if you have your jobs over on the other side in these system databases, templatize, which is what the contained AG is based on. Yes, bring those in. Yes, so I don't have to do that again, and it makes it easier to get back on your feet. Some key things here. Contained availability groups are a synchronization mechanism, not a security mechanism. So it is possible for you to be able to join other objects outside of the contained AG. It's not a security boundary. The idea is to replicate logins, users, settings, and jobs between databases. It's important to note that contained AGs can still access anything outside of the database scope. So to interact with the contained AG, for that perspective, you really need to be going through the contained availability group listener or specify a database within the context of the AG in the connection string, as I've shown on the slide here. Okay, so it's really important to have that listener for the contained AGs to effectively use it, and the database names have to be unique across all the instances. So essentially the magic that's being done here is the system databases are key to this, and you'll have a templatized system database for each AG that's part of the contained availability group. Each AG have its own specific AG master and MSDB. So like accounting availability group would be accounting AG underscore master. The MSDB would be accounting AG underscore MSDB, part of the accounting AG availability group. If you're not going into that instance under the lens of the listener, let's say you're the DBA, you're the sysadmin, you will literally see those objects the way I described them. If you're a user and you're going in through the listener, or whatever user account going through the lens of the listener, that would be masked to you. You would just see MSDB. You would see master as it were from the scope of the contained availability group. Okay, so let's take a look at this, and Kevin has some good context to this scenario. Audio's not coming through here. Okay, so essentially, I'll step through this because I expected the audio for this. So essentially what he's got is he's got a script that does all the commands. It's running in SQL CMD mode, so it can connect back and forth between the replicas. So, oh, I thought I heard audio coming through.
We'll create health sessions, and then we go to the secondary replica.
Yeah, it's up as high as we can go. Yeah, let's try that. Oh, wow. All right, let's see how this goes.
Hi,
That's
I'm
fine.
going to do a quick demo
Thank
of
you.
creating a contained availability group. I've got a script here that does all the steps. You know, it's running in SQL CMD mode, which means that I can connect back and forth between the two replicas, which makes the whole operation a lot simpler. So the first thing that we're going to do is create the endpoints. Now we'll connect on the endpoints. Note that we're going back and forth between the replicas. Next, we'll create the always-on health session, and then we go to the secondary replica and do the same operations. And then we'll create the availability group, and you note the only new syntax is
Only
contained.
change are the contained keyword.
So we're going to go ahead and start from the beginning. Create the endpoints, create the availability group, you add the listener, then we connect to the secondary, and join the availability group. So that's running. So according to the results, everything went fine. So let's look. Here we refresh, view,
This is important.
and we see all the objects. You see we have test CAG, which is the primary replica, and we have the different availability
See, in the
replicas
context of
and
the
databases.
instance, you're seeing underscore.
Note there's a
max,
couple of
underscore
new
missing.
databases. I had wide world importers to start with. Now we have test AG, the name of the availability group, underscore master, and MSDB. This is a mechanism we used for keeping the contents of the master database in sync across all the replicas. So now what I'm going to do is reconnect
Through the lens of the listener.
test AG underscore LSN1,
Which is what you'd
Which
want to
is the
do when
listener
you're
for
creating
the
the new jobs. You're
contained
creating your login.
availability group. We're connected to the contained availability group through the contained listener, which is what gets us into the environment of the contained AG. And then we're going to create some agent jobs, something that you normally would do and normally would have to go around to the other nodes and do the same job, create the same jobs, and make sure that they're executing in sync. We've done that now. So how do I show that everything has gone the way I say that it should? I'm going to connect first to replica 1,
Availability group.
and then to replica 2, and then to the listener. At each point, I'm going to select add server name, the physical server that it's running on, and then do a select from sys jobs. So again, here test AG1, the instance doesn't show any agent jobs. Test AG2 also doesn't show any agent jobs. The AG happens to be running on test AG1, and you'll see that there's the agent job there. So all of this works good. So now I can go into test AG primary and failover to see what things look like from the other side.
So did the job replicate to the AG2?
Connect to the other side.
Viewing it through the lens
And
of the
start the failover.
instance, not the listener in this case.
I have success there. So now what I can do is to connect, change connections. So I can connect to the listener, test AG LSN1, which should be running on test AG2, and run the same query. And you'll see that indeed we are executing on test AG2, I didn't copy it across, but now that we're running on the other replica, we have the same set of agent jobs, and that's the power of contained AGs.
Okay, so notice in the Object Explorer, each time we're connecting in, looking at the instance level. That's why you saw the underscore master underscore MSDB. Through the lens of the listener, you saw the job. After failover, the job was there, and that is the power of contained AGs, but must be done through the context of the listener. Is it a standard listener to the availability group? Or is it a standard listener to the availability group? Yes. So it is to the contained availability group. So it's a regular listener to the contained availability group. Is it keeping the system database's master model in sync? When you create it, it will create the sysadmin connection. Then any jobs or users that you create must be created to the context of the listener for it to be replicated. It's essentially using a template of master and model to accomplish this. I would have to look into that last question. I'm not 100% sure on that one. Is it possible to create? Yeah, is it possible to create a contained master and MSDB database on GUID? G-U-I-D? I don't know. I'll have to look into that one. Okay. So for the sake of time, really close, 10 minutes, I'm going to try to wrap up. T-SQL Snapshot backups. So its capability is definitely a powerful one if you've invested in hardware storage solutions capable of performing hardware storage level snapshots, especially if you have really large databases. So in the context of SQL Server, streaming means the backup process reads data from the database and writes it to the backup files continuously without interruption. So it could take a lot of resources to accomplish this. Very large databases require a lot of resources to consume this. So basically, the bigger the database, the more the overhead. One of the ways to handle this, yeah, I'll get back to the question. So one of the ways to handle this is to use a snapshot backup mechanism for your underlying storage provider. But it's an external process. So it definitely helps to be able to leverage the snapshot backup scenario, but it is not native, or it wasn't native until SQL Server 2022. So with this capability in 2022, you can freeze a database with an alter command, perform snapshots in multiple databases simultaneously using the new backup group and backup server commands. So if you need to have, let's say you have 5 databases, and those 5 databases need to be in lockstep. I need each of those ones to be simultaneously replicated. You can do that using a backup group command like this. I want to state that group does not connect to an availability group concept. It's just a listing of databases, though it makes perfect sense if you were to use the same databases and list them out as part of an availability group.
Does that apply to primary and secondary databases?
Yeah, it would be any databases that you're backing up. You can do, yeah. And the BKM is just the metadata. So you're essentially, the only requirement is that the storage provider provides the ability to do snapshot backups. Yep. So you're essentially using that through T-SQL natively. And if you want to suspend all databases on a server for snapshot backup, this is the way you would do it. Okay, so tight on time, but I definitely wanted to get to this next concept. Okay, so accelerated database recovery. It's a database scope option in SQL Server. 2019 is when we started with this. Greatly improves database availability, especially in the presence of long-running transactions. It's a completely redesigned recovery process. Okay, so it tends to be when you have a lot of mission-critical databases. Mission-critical databases that are large, have long-running transactions, tend to have impact to the transaction log, especially if you're doing like a bulk insert, something big like that. And recovery is paramount, so you run into this situation where you're struggling from a failover perspective. It could be crash recovery perspective. So ADR is huge for that scenario. There were challenges in 2019, so we'll talk about what we did in 2022, and we have a demo on this here as well. So Before 2019, you had these kind of issues with disaster recovery, just slow recovery times, because we had to scan the entire transaction log and rollback times for large transactions, and transaction logs consumed significant amounts of disk space because the database engine could not truncate the log when any long-running transactions were active. It could be definitely problematic in the presence of long-running transactions. I mentioned like bulk insert kind of scenarios, but you could also see this like an index build situation as well. So the bigger the database, the bigger the workload, the more mission critical, the bigger the impact. And that's kind of what we are seeing here and what became a really big customer pain point. So without ADR, okay, we've always had these three phases: analysis, redo, and undo. And SQL Server scans the transaction log from the last successful checkpoint to determine the state of the transaction, to bring the database to a state it was at the time of the crash by redoing all of the committed operations and undoing operations performed by each active transaction at the time of the crash. Could be long. Okay, thank you. Canceling a long-running transaction could definitely take a long period of time. So the key thing here, I guess, is the databases were previously only available after the full redo and the full undo operation. Okay, so what we did is we've redesigned this. So starting with 2019, ADR redesigned the recovery process to make it nearly instantaneous.